Today we're going to be talking about molar mass, and molar mass is defined as the mass in grams of 1 mole of substance of an element. And so it's going to have units of grams per mole, so it's a mixed unit, G/mol. And that basically says that some number of grams is going to equal 1 mole of that substance. So whatever this number of grams is that equals 1 mole of the substance, that's the molar mass of the substance. Okay. What's really helpful for us is the mass, the molar mass is equal to the atomic mass, the average atomic mass from the periodic table. So if you look on the periodic table, you remember that decimal number that we've been referring to as the average atomic mass. That is the same thing as the molar mass. So you can look on the periodic table, look for the decimal number, and you can identify what the molar mass will be. So for zinc, the molar mass is 65.39 grams per mole of zinc. What that means is that when we have 1 mole of zinc, it's equal to 65.39 grams. All right. So what we can do is we can calculate the molar mass of compounds. So we talked about the molar mass of just an element, but when we have a compound, the mass is going to be additive. So for H2O, we have 2 H's, so we've got 2 H's, and we've got 1 O. And so what we can do is we can just add up the individual molar mass, multiplying by how many of each type of atom there are. So we've got 2 atoms of H times H has a molar mass of 1.01 grams per mole. Okay, so that would be 2.02 grams per mole of the molar mass of water will be from the 2 H's. Oxygen has a molar mass of 16.00 grams per mole. Okay, and there's only 1 oxygen, so we'll just continue that over. Okay. What we need to do is we need to add these up. So 2.02 and 16.00 would be 18.02 grams per mole. So what this is telling us is that for every 1 mole of water, there are 18.02 grams of water. Okay? And when you see it written out this way, you can say, wow, that looks awful like a conversion factor. Okay? And it is. So we can use molar mass to go from grams to moles, or if we're given moles, to convert to grams of a substance. And this works for either elements or for compounds. Okay. Let's try one more example together. So for PF3, we're going to first identify what the molar mass is. So for fluorine, it's 19.00, and for phosphorus, P, it's 30.97. So these are found on the periodic table. Okay. And what we notice is there's going to be 1, right? There's an implied 1 if there's no subscript, 1 phosphorus, and there are 3 fluorines, so 3 times this. So you're going to do phosphorus times the molar mass here, so 30.97 grams per mole from the phosphoruses, and then 3 fluorines, so 3 times 19 would be 57 grams per mole. You can then add those up. So this is from the phosphorus, and this is from the 3 fluorines, to get our molar mass of 87.97 grams per mole. Again, that is a conversion factor. 87.97 grams of PF3 equals 1 mole of PF3. So now we're going to do an example of how to use molar mass as a conversion factor. So this example says convert 1.5 moles of CO2 to grams of CO2. So we're going to set up some dimensional analysis, starting by taking our given information, which is moles of CO2, and putting it over 1. So we go 1.5 mole CO2 over 1. We're then going to set up a second fraction, and what we want to do is we want to put the molar mass into this fraction as a conversion factor. So we first need to do some work on the side to figure out what that molar mass is going to be. So I've got CO2. So I've got 1 times carbon, and I've got 2 oxygens. So 1 atom of carbon has a molar mass of 12.01 grams per mole, and 2 oxygens have a molar mass of 16.00 grams per mole. Okay. When I simplify that, I have 12.01 grams per mole plus 32.00 grams per mole, and I get a total of 44.01 grams per mole. Remember that that is like saying in 1 mole of CO2, there are 44.01 grams of CO2. So that's what's going to be put in this fraction right here. So let's do that. We have moles in the numerator to start, so I'm going to put my moles of CO2 in the denominator, and I'm going to put my grams, my desired unit, in the numerator. I'm then going to take my numbers, so 1 mole CO2 will match up right here, and 44.01 grams is going to match with the unit of grams. So my units are going to cancel out. Moles of CO2 cancels out moles of CO2, and I can do some math to simplify. So I will multiply the numbers on the top, 1.5 times 44.01 grams, divided by 1. When I do that, let's get our calculator out. 1.5 times 44.01. I get an answer of 66.02 grams of CO2. Great work.